Hello and welcome to today's Machine Design webcast. Our topic today is robots are on their way to Industry 4.0, sponsored by TTI and TE Connectivity. I'm Bob Vaver with Endeavor's Design and Engineering Group. Let's talk about how you can participate in our presentation today. If you have any technical difficulties during our session, simply type the question into the Ask a Question box, hit submit, and a member of our team will assist you. You can also click on the question mark button on the upper right-hand corner of the screen. We also welcome your questions during our event today, and we'll get to as many of those as we can during the Q&A session that will follow the main presentation, so feel free to send in your question at any time. To do so, simply type your question into the Ask a Question box and hit the Send button. If you'd like a copy of this presentation, please click on the Event Resources tab on the side of your screen to download the presentation. Also be aware that today's session is being recorded and will be available on the Machine Design website within the next week. You'll be notified by email when the archive is available. So let's meet our speaker for today. Michael Steuer is the Global Account Manager at TE Connectivity. He's worked for 25 years in sales, technology, business development, and product management. During his time there, his background and experience, he's eager to help us understand the opportunities present and awaiting in Industry 4.0 that help us build a robust product and technology pipeline. So, Michael, good afternoon and welcome to our presentation. We're looking forward to the presentation today.
Thanks for the introduction. Hello, everybody. Thanks for joining today's webinar, Robots are on their way to Industry 4.0. My name is Michael Steuer of TE Connectivity Industrial Business Unit, my home for the last 25 years. With some excursions into other businesses of TE. Today, I would like to give you an overview of the Internet of Things, talk about use cases on a high level, the CAGR 2018 to 2025 to highlight the attractiveness of this market, the trends, Internet of Things in general, and the TE's offer. Then we move over to robotics. The robotic classification is a refresher what is out there in the industry. The robotics architecture helps us staying focused and to classify products. And the top robotic trends will help us to understand where the road goes. And finally, a short market outlook will follow. We will then look at TE's portfolio, and you will learn what we have to offer for robot applications, in particular, robot manipulator, or the arm as it is called, and the robot base, the gripper, and the robot controller. And finally, last but not least, the teaching panel unit, or in short term, TPU. At the end, we will look at the sensor offering of TE Connectivity and will especially look at the torque sensor designed for cobots, as well as the general sensor portfolio. The last slide refers to important landing pages to help you find your way within the TE website tailored for robotics. The robotics landing page, by the way, has just been launched officially, so right in time, I would say, for this session. We all know that robots and cobots are on the move into smart factories. Brought on by the rise and acceleration towards the fourth industrial revolution, industrial Internet of Things and cloud computing are changing the way the robotics market exists and operates. As the opportunities continue to progress and grow throughout the global manufacturing footprint, humans and cobots will soon work side by side in what it is called smart factories. For this, we need reliable, safe, and robust connectivity, along with precise sensors. The idea of the Internet of Things, or short IIoT, is that everything is connected with everything and everywhere. Like when you drive a newer car, you have all the important data of your car on your mobile device app, can control basic functions and understand the status, if windows are open or closed, when a rain shower approaches, or if the car is locked when you're far away. Smart homes can be controlled with a mobile phone, and with connected services and connected security cams, you can monitor the inside of your house everywhere in the world. So IoT is already there and will further evolve. The IoT use cases are divided by industry IoT, which is called IIoT, and the consumer IoT. The advantages of connecting everything in the industrial environment are obvious. You can monitor your entire supply chain from incoming goods through processes up to the warehouse. This will help you to increase the efficiency in the entire factory. Flexible manufacturing with lot sizes of 1 with highest quality standards become realistic. With connected services everywhere, you will see improved safety in the manufacturing, and it will allow you to better manage the energy consumption. Connected services enable you to gather all relevant data, making it easier to optimize your manufacturing. Virtual setups help programming and further optimizing the task of machines, and predictive maintenance helps to plan line downs due to necessary maintenance work. Sustainability will increase due to this. Localization-based services enable the collection and transmission of data to determine the target position through, for example, RFID tags or GPS modules in the manufacturing site. Remote services will further help to control and adjust remotely or get expert insights through sharing the status of your workflow. So IoT is not only an interesting market from the technology challenge point of view, but also financially very attractive with a CAGR of around about 11%. In this page, I clustered the very fragmented market to make it fit for the business units of the connectivity. You can see that industrial and automotive cover the biggest market growth in this area. I rated everything that does not fit to TE business units as channel. So please do not get confused. TTI's reach for sure is not limited to this. Looking at the trends, the architecture is moving from a hierarchical system to a fully cloud-based system. In the cloud are already enterprise resource planning, product lifecycle management, and manufacturing execution systems, while controlling takes place in the field. With this, you will have an end-to-end service-oriented architecture with bidirectional information flows. It is all about sensing, processing, and acting, where robots are a vital part of the system. The resulting trends are smart sensing, increased field connectivity, decentralized intelligence, as well as data processing. We did a survey with our customers to understand what is important for them and what are the challenges they are facing. 5G networks with faster speed and low latencies will lead to new applications and will support their factory setup. The ability to capture different kind of data and gathering more data transfer from applications and to be able to identify weak spots in the manufacturing and further optimize will lower the cost and the carbon footprint and lower current consumption in Internet of Things devices. The importance of smaller components will reduce the footprint of an installation. Hardware endurance increases due to predictive maintenance. Measurement accuracy will help to further optimize. Sensor intelligence will improve quality through a higher precision. Processing speed will reduce cycle times. Cloud analytics will reduce local hardware efforts. And miniaturization is required. Today, our customers see challenges in the hardware, the connectivity, the security, and the software and cloud computing. What we can offer to help our customers with their challenges are a strong support in the modular device through tailored and smart connectivity to be able to process higher data rates and the application know-how of our focused teams. And smart and intelligent sensing. Not many people know about this, are also a core competence of TE. Now, as we understand the environment of Internet of Things, let us look into robotics as a key application on the factory of the future. We all know SCARA, parallel or articulate robots, helping us since years to optimize processes in the plant. However, especially our articulated friends need a cage where they are operating on a high and precise level. To enable the collaboration with human beings, cobots found their way into today's manufacturing, including autonomous vehicles who will replace the traditional forklift for routine processes, especially in warehouse automation. Consumer robots and drones, amongst others, are also existent, but not in the focus of TE Industrial today. The basic robot architecture of articulated robots is based on the manipulator with its base, a vast variation of grippers for various applications, a controller, as well as the TPU, the teaching parent unit. We have clustered the connectors suitable for each subcomponent, and I will come to this later. Before we will get there, let us look at the trends that we see in robotics. I would like to recommend the ifr.org webpage, as shown on the top right, to get more detailed information if you need. With improved processors and software, robots today learn new tricks and can be used in a wider field. Especially the cobots are a driver of smart factories, and their ability to work side by side with human beings allows them to enter new markets. As a robot is precise 24/7 at max, the carbon footprint can be reduced tremendously. The Corona crisis did prove that robots can also secure the supply chain, as a lot of tasks can be done completely autonomous, and social distancing, as prescribed by governments, was possibly without losing the efficiencies. So looking from a customer point of view, they want more customized solutions to increase the productivity in their plants. Shorter life cycles of the products, take smartphones as an example, are supported due to flexible programming of robots. And to help building up automated systems fast, the robot has to be modularized, consisting of building blocks like a Lego. Even the long-run perspective for robotics stays excellent. There are still many dull, dirty, dangerous, and/or delicate tasks, the so-called 4D tasks, that could be done by robots versus human beings. This will improve the workers' health, safety, and finally, job satisfaction. Most extreme robots to help are to disarm bombs. Well, but it's a good example. Also, the aging society triggers additional needs to relieve employees from physical tasks, and technological development will increase the return of invest in robotics. Not to lose time during transportation from A to B within a factory, matrix production layouts use robots for automatic workplace transportation, and certain tasks can be done during the transport. Needless to say, modern robots support a smaller carbon footprint through precision and reduce waste and a better first pass yield. Human-robot collaborative applications will complement traditional robotics. For instance, one of a major EMS bought thousands of cobots instead of hiring additional people for simpler tasks. The plug-and-play system orientations makes development easier, like open platform communication in the unified architecture. And the ease of programming, like through demonstrations, makes redeployment easier. Means cobots are now also used in small and mid-sized companies, as you do not need high invests, a special infrastructure like cages or a specialist to program them. It is about simplification and the ease of use. The market outlook underlines the robotics is worth putting focus on. The annual installation of robots was slower in the last 2 years, but the trends are showing that the market continues to grow double-digit. Operational stock is at 2.6 million pieces globally as of 2019, and I think we will come close to the 3 million pieces in 2020. So let's wait for the latest reports. And although the largest amount of installations are in Asia, dominated by China and Japan, combined Europe and the US are at 3 and 4. And especially when you look at the installed robots per 10,000 employees, EMEA has the highest density, followed by Asia. Cobots today have a very low share in the overall robotics market. However, given the fact that they are fairly new and have high growth rates with hundreds of new and innovative players coming to the market, their share will soon reach double-digit. So what can T offer to help serving this fast-growing market of robots and cobots? As shown before, we clustered the different connector families to the sub-applications. For the robot arm, the manipulator, we can offer a wide range of power, signal, and data connectors, along with a high sophisticated torque sensor. Let's begin with the industrial mini I/O connector. It offers various board and cable connectors, right-angled straight board connectors, as well as solder and piercing cable connectors for our harness makers. Also for the field installation, there are IDC-based cable connectors with automatic wire cutoff for toolless installation and a controlled return loss at higher frequencies. Our mini I/O connection supports power over Ethernet, PoE+, and PoE++. Data rates from 10 megabits per second to 10 gigabit per second are supported. The special contact design protects from interruption in high vibration environments, and the design consumes only 25% of a standard RJ45 connector. The dynamic D1000 slim small wire-to-wire connector is suitable for narrow spaces in small industrial equipment and small machinery applications such as cobots, where space in the arms and joints are limited. The size of the D1000 is 80% smaller than at the D1200 series, with low interference risk and streamlined design. Keying and the locking feature provides reliability and reduces unexpected unmating and lever breakage in narrow spaces. The benefits are a smaller size increases the connectivity per use space, a reduced risk of connectors breakage by interference in narrow space, a reliable increase as the user can hear when the connector is properly locked by a click, and an easy mating and crimping process to speed up installation time. Now let's come to intercontact connectors. With these intercontact connectors, you can now benefit from a large variety of solutions that make connecting easy. Intercontact connectors enable modular designs which make them highly compatible in many different combinations. Whether you need to connect power, signal, or data, or all combined, these connector solutions provide a custom solution for your application. With their plug-and-play concept, these connectors enable easy and quick installation, as well as easy replacement for defective parts. The assembly is possible without any tools and is particularly easy due to innovative concepts like the chrome clamp, which allows the shielding mesh to remain uncut. With the innovative 1/8 quick locking system, intercontact connectors drastically reduce installation time and the risk of failures during installation. And thanks to their reliable performance, the connectors also help reduce downtime, making the application more productive. And then heavy-duty connectors. They are well established for decades already. These rectangular industrial connectors are designed to transmit power, data, and signal in the toughest conditions. In environments with vibration, risk of dust, temperature challenges, and mechanical impact, our HTC connectors provide a reliable solution with rock fail safe aluminum enclosures with protection degrees from IP65 up to IP69K. Approved according to EN IEC 61984 standard, our HTC connectors range from 10 amperes up to 650 amperes and are available with up to 216 contacts and a modular system that allows to use dynamic contacts for both power and signal, as well as circular and rectangular data inserts. For a safe and reliable communication, our M8, M12 connector systems provide a full solution that includes connectors, I/O modules, and cable assemblies. Needless to talk about this well-established product. Our RJ45 connectors are well-known rectangular data connectors designed for Ethernet networking. However, our design is made for robust industrial applications. Data rates of up to 100 megabits per second and 1 gigabit per second are supported. Ethernet magnetics as discrete parts allow for custom Ethernet port layouts optimized for EMC and or overvoltage. All Ethernet magnetics are SMD and reflow solderable. Our field installable cable connectors are available for 2-pair and 4-pair cables up to 10 gigabit per second, supporting Cat5e, Cat6, and Cat6a performance. The toolless installation with automatic wire cut helps to ensure a high quality connection together with short installation times and a controlled return loss at high frequencies. Our CPC connectors, also proven to be reliable for decades, are polarized for proper mating of connector halves with removable contacts and a replaceable coupling ring that makes field repair easy. They are made of stabilized, heat resistance, self-extinguishing thermoplastic material. Known for performance reliability, our circular plastic connectors can be used practically anywhere signal and power either enter or exit a system. Versatile and rugged with a cost-effective design, CPCs are used in various industries, also in robotics. They come in 6 different series to allow you to choose the product best suited to the design requirements and the lightweight plastic makes the perfect fit for robotics applications. Now let's move to a higher sophisticated product, our torque sensor. As we learned, the demand for collaborative robots is growing fast. And we have learned that we know that these cobots must work in a safe environment alongside human beings. With the torque sensor, we have a solution to provide functional safety in the next generation of human-robot collaboration with increased accuracy and speed. Our ring-shaped safety torque sensors are designed to be integrated at each cobot joint, meeting the new level of safety requirements up to ISO 13849 category 4 PLE. Optimized for cobots, the sensor provides low susceptibility to crosstalk, allowing increased accuracy. With available customized mechanical interfaces, the sensor can be easily adapted to meet specific customer application requirements. And with a standard digital interface, the sensor allows easy integration into the system. The safety torque sensor incorporates proven microfused sensing technology with excellent long-term span and zero stability. During the next pages, I will also show a video that explains a little bit more about this sensor. For the gripper or the hand of the robot, we have identified the M8 and M12 connectors, industrial AG45s, also with plastic housings to reduce weight, the Mini IO series, as well as the Intercontact connectors. Needless to repeat their values again, as I have explained them before. For the robot controller, though, more connectors and relays come on board. I highlighted the dynamic 1000 Slim series earlier, and the entire series ranges from signal level to power connectivity, all in a ruggedized, industrialized package. Dynamic connectors are designed for use in control system applications to suit high density signal and power applications. These wire-to-board, wire-to-panel, and wire-to-wire connectors have diverse housings, and while standard crimp and spring clamp variations of parts are available, standardized contacts limit the amount of application tooling required for these connectors. And finally, what is a cabinet without a relay? We have extensive capabilities in the design and manufacture of relays and a broad portfolio of switching solutions for demanding high-performance applications. Complying with the standardized PCB footprint, we offer a wide range of inrush current capabilities and address the complete spectrum of requirements for robotics, an array of safety critical applications, and others. Through agency-approved test labs, we ensure that our relays are tested to meet the expectations of the industry. We have a perfect landing page for relays that can be found under the robotics landing page. I have included the link on the last page of this presentation. And this will help to find the relays of your needs. The TPU, the teaching parent unit, is used for programming and to control a robot remotely. Intercontact, heavy duty, and CPC connectors, all reviewed before, are suitable. We already talked about the torque sensor. And before I provide a quick overview of the different sensor types we have in addition in our portfolio, I will not miss to show a short video. Thank you. Now with the drive towards Industry 4.0, the use of robotic automation and control systems on the factory floor have become commonplace to increase efficiency, productivity, and profitability. As the need for industrial robotics automation advances, sensing technology will continue to be the foundation for data collection that will help transform manufacturing floors into connected, cost-effective, and reliable facilities. We offer numerous force, temperature, pressure, and position sensors that provide highly accurate managements for precise movement control and accurate monitoring of systems, components for preventive maintenance. With this, I would like to thank you for your time. I hope I could have provided a relation between the Internet of Things, robots and cobots, and TE's offering of connectors, relays, sensors for this market. As you might know, we also have filters, PCB connectors, labels, and much more in our portfolio.
Thank you for attending this webinar. You will soon receive an email from TTI with information on how to acquire samples and/or request a meeting with a technical design expert. We have time now for our Q&A session.
Thanks, Michael, for the presentation, and we're going to get to our Q&A here in just a moment. A few of you have already submitted questions, but if you'd like to submit a question for Michael, type it into the Ask a Question box and hit the Send button. Also, please take a moment to complete the feedback form that will appear on the bottom of your screen at the end of the webinar. We've got a few questions we want to get to from the audience, Michael. Let's start with this. What kind of EMI solutions for power noise does TE have in the portfolio of hybrid power and signal robot interfaces?
That's actually a good one. Thank you. We have some good solutions like the Intercontact 723 series, and the newly launched HTC dynamic hybrid inserts for small payload robots and controllers. And together with an HMN shield module, this is suitable for flexible combinations.
Another one talks about this. Cobots are usually in a slim design. So what kind of solutions does TE have to ensure a robust connectivity?
Well, I did show it earlier in the presentation. Our dynamic 1000 slim series has been designed to meet cobot requirements. Especially the joints, are challenging due to the small size. And with a 12 precision connector at 14 millimeter diameter only, we have developed a suitable connectivity together with our customers. And also the mini I/O, we should not forget. This connector is only at 25% of the size of an RJ45 connector with a vibration and acceleration-proof contact design suitable for robots. And I mentioned this also earlier on the slides.
And what makes the D1000 so interesting for cobot customers?
Well, I just mentioned it. It is about the size and the density. So 12 precision at 14 millimeters and the current capability of 4.5 amps per contact. But for sure, you need to take the rating curve into account. So you cannot load the contacts full power, but individual contacts can carry 4.5 amps. That's a lot.
And talk about the TE relays and what kind of relays are the best fit for robot applications?
But I would say that depends a little bit on your application for sure. So we have safety relays or the SR relays and IM relays for safety functions on a PCB. And then we have the RT and RSET together with the T9G and PCN relays for servo drive function. I mean, servo drive is a part of the robotics. Without a servo drive, you cannot carry a motor. Yep, that's.
And let's talk a little bit about the future.
Okay,
go ahead. I was going to say, let's talk a little bit about the.
Go ahead, Bob. Sorry.
Let's talk about the future trend for interface connectors in the robot controller.
Yeah. So first of all, sorry. I mean, we obviously have a delay in the line here. So for small and medium payload robots, one of the estimated future trends is the one integrated connector, which has power and signal, right? So against the existing two connectors we have right now, where power and signal is separated. And we can provide solutions such as the Intercontact, hybrid series, HTC dynamic hybrid module with power and signal.
Let's talk a little bit about how you see sensors evolving in the next 5 years. We've written a lot about sensors and their proliferation, and really that's one of the biggest things driving the growth in IIoT. How do you see that evolving over the next 5 years?
Yeah, sensors will, in the next 5 years, or maybe a little bit longer, but they will definitely directly communicate to the cloud. So they don't need a hub where they report their status. They will directly report to the cloud. And to make this wiring easier, we think energy harvesting technology is required to make sure that the sensor is always powered. So, I mean, there's a lot of acceleration on the robot arm where the sensors are, right? And if you harvest this energy of acceleration, then you have something that can work quite independent.
Good. Another question's come in from the audience. When you talked about high temperatures that the robots can endure, how high actually is that ambient temperature?
I mean, that depends also where these connector on the robots, right? I mean, we have connectors that are for higher temperature applications for 120 degrees, but usually at 80 degrees temperature. That is kind of a market standard.
Okay. I think we have time for one more here. It says, the question from the audience is, which of your product range, connectors and sensors, are more suitable for drones, considering reliability, weight, and density?
So when you look at drones, right? I mean, this is really, well, you have the motor control. So you go to the very small connectors, which are the PCB connectors, series that I didn't show here. Not necessarily suitable for industrial robots, but it's yeah. So what series do we have? I think micromesh series connectors are always suitable, and other industries from TE. So very low-cost data connectors, as well as appliance connectors, small size, are more suitable for drones.
Well, that wraps up all the questions we got from the audience today. If we didn't get to your question for some reason, we'll be getting back to you via email. So, Michael, I want to thank you for a great presentation today. And on behalf of Machine Design, I'd like to thank TTI and TE Connectivity for sponsoring today's event. And of course, thanks to all of you for joining us. Have a great rest of your day and stay safe out there.
Thank you very much. I hope you enjoyed it. Thanks.